Welcome to this video, the 8th video in my series of videos on Cantor's 1895 and 1897 articles on the theory of aggregates and transfinite numbers. Section 8 is titled Addition and Multiplication of Ordinal Types. Addition for ordinal types is defined on page 119. It's noted that the ordinal type of a union aggregate with the described ordering relation depends only on the ordinal types of the individual aggregates. Importantly, Cantor points out that the addition of ordinal types is associative, but is not commutative. The proof of associativity is trivial. A simple example is given to show that commutativity does not in general hold for ordinal types. Finite ordinal numbers do commute under the operation of addition, and we'll see in section 19 that under certain conditions there are some examples of transfinite ordinal numbers, which are a special kind of ordinal type, which commute. This failure of ordinal types and later ordinal numbers to commute under addition must always be taken into consideration. Ordinal arithmetic can sometimes resemble normal arithmetic in many ways, particularly with the use of the addition symbol or multiplication symbol, but we always have to be conscious of the fact that an addition symbol between two ordinal types does not have the same meaning as an addition symbol between two numbers in, say, normal elementary arithmetic. For the next part, which leads to a suitable definition of multiplication of ordinal types, the aggregate S is formed in a similar way to the S of section 3 on page 93. The essential difference here is that the S formed has an explicit ordering defined on its elements. The first criterion says that the order within each M sub n, when considered as part of S, is the same as the ordering of M sub n when it's considered as a completely separate aggregate. The second criterion says that the ordering between the M sub n depends on the order in n of the subscripts. That is, if n1 precedes n2 in n, then all elements of m sub n1 will precede all elements of m sub n2 in s. And similarly, if n2 precedes n1 in n, then all elements of m sub n2 will precede all elements of m sub n1 in s. As with addition, the ordinal type of S with the described ordering relation on its elements depends only on the ordinal types of the individual aggregates which form S, and the specific nature of the objects of each aggregate is irrelevant. I'll show on the screen some of the details relating to the proof of associativity of ordinal multiplication. This is really just to clarify some of the notation used more than anything. Distributivity can be shown as on the screen now. As with addition though, multiplication of ordinal types is not commutative in general. Again, we always have to be conscious of this when doing any ordinal arithmetic. A simple example shows that multiplication of ordinal types is not commutative in general. Cantor states that any arithmetical statement that can be made for ordinal types can also be made when the ordinal types are replaced with the appropriate cardinal numbers. The converse is not true. There are arithmetical statements that can be made for cardinal numbers, which do not hold for ordinal types. Commutativity of multiplication of cardinal numbers is one such example. Thank you for watching. If you found this video useful, then please hit the like button and subscribe to my channel. You can see more videos on various topics on my channel, and if you have any suggestions for topics for future videos, then please feel free to let me know, and I'll try my best to put something together. Don't forget to hit that subscribe button and keep an eye out for new videos being uploaded to my channel.